Okay, so I had problem 27, which is a 40-kilogram child takes a ride on a Ferris wheel that rotates 4 times each minute and has a diameter of 18 meters. And then there's A, B, C, and D. So A is, what is the centripetal acceleration of the child? So, to write on the givens, the mass is 40 kilograms. This is 4 revolutions per minute. The radius equals 9 meters. And you can draw this. So 9 meters. And then label the positive y, positive x. Notice how I label the positive x going that way, because that's the way the acceleration is going. So for A, the centripetal acceleration is equal to v squared over r. And then you need to find v, so you can use the equation v is radius omega, because you have this, but you need to find that, the v. So 9 meters times 0.42. Oh, hold on, sorry. To find the, you need to change that, the revolutions per minute to radians per second. So you have to do 4 revolutions in 1 minute. So 1 minute. Radian over 1 rev. And then revolutions cancel, so that's radians per second. And you get 0.42 radians second. So you go back over here, and then so you use the new W that you found. The velocity is equal to 3.76 meters per second. So you can use these 2 new things that you found and plug it into there. So go here, 3.76 meters per second squared, 9 meters, 1.58 meters per second squared. This will be useful a lot later on in the problem. And then number B, letter B, is what force does the C exert on the child at the lowest point of the ride? So this is B. So the child is going to be right here. Center is here. Same y plus x. There is going to be mg down. I just call this normal force, even though I'm not really sure it is that. It's just like the force going upward. And that's it at the moment. So then you sum the forces. Is equal to negative mg, because it's down, plus the force going up is equal to m, and then this centripetal acceleration. So then the new that will equal, and then you plug in the numbers. So it's equal to 40 kilograms times 1.5 meters per second squared. This is what you found earlier. Plus 40 times 9.8. And then you end up with the force being 455.2 newtons upwards. And then C is what force is exerted when the child is at the highest point of the ride. So for C, this would be when the child is up here. So it's still, and then here you would sum the forces again. It's is equal to mg minus this time the force. And then it's equal to the force, and then you just plug in the numbers again. And then that equals the force, and then you get the force equal to 328.8 newtons up. So this is just different from the last one because here the mass times acceleration is negative, and in the last one up here it was positive, and then negative. And that's C. And then for D, it is what force does the C exert on the child when the child is halfway between the top and the bottom. So then I just drew that, so it's there, and then I labeled mg being down, and then the force of the seat going upwards, and then the force of the seat going towards the center because the seat is keeping the child in place. So then you would sum this forces, y plus mg, what is mg, sorry, is equal to a, and then force of x is equal to mac. So then I just plugged in, so force of the seat y is equal to, this goes to 0 because it's not moving in the y direction, mg, and then mass times gravity, which is equal to 392 newtons. So this is for the y direction. So you can just draw a triangle over here, and this is 392. That's going to be used later on. And then force seat x is, so then I solved it for the x direction. I did the force of the seat x is equal to the mass times the centripetal acceleration. And I got that, and then I put it on the x direction, and then you have to solve for that using the Pythagorean theorem, and you get 397. And then you have to find, they want the magnitude, so they find the degree here. Sine theta equals 392 over 397, and then you do the inverse, so -1 times, and you get 80 degrees. So the total force is 397 newtons at 80 degrees.